So this is EECS LAB 3.
EECS LAB number 3, the interface breadboards.
After step 1, once we had gathered all the materials for the lab, we began on step number 2. We connected the interface board to our laptop using the USB cable provided. Then we used the multimeter to verify that the 5-volt line on the interface board is providing 5 volts relative to the ground line on the board. We did this by inserting the red multimeter probe on the fidget interface board to the plus 5-volt terminal and by inserting the black multimeter probe on the GND terminal. Using a similar setup from step number 2, we began on step number 3 where we measured the voltage for each of the 8 digital outputs of the board and verified that none of them are active, since we got 5 volts for each, as you can clearly see. Similar step number 3, we began step number 4 in which we measured the voltage of each of the 8 digital inputs and verified that none of them are active, since we got a value of 0, as you can clearly see. Step 6, we launched MATLAB and loaded the first .m file. In step 7, we then ran the file using the run button. In step 8, we then pressed enter when prompted to do so, knowing that pressing enter again would terminate the function. As the first .m script was running, we used cables to connect digital input number 1 to the ground terminal of the interface surface board. What we noticed is that as we changed the inputs on the board, we got different inputs for the system as well. And there's different values you can clearly see on the system. Step 10, we terminated the function and the output is clearly visible on the screen. We then began step number 12, in which we uncommented the statement that sets the digital output number 3 to logic value 1 in the comment section, along with a statement that displays the count as well. We then saved the program and ran the function, which gave us the following output. We began step 16 by copy and pasting the statement that sets the output value to 1 and the pause statement below it. Then we edited the two statements so that the first one sets the digital output value to logic value 1 and the second statement sets the logic value 0. After saving the file in step 17, we ran the program in step 18 and verified that it counts the number of times digital output number 3 was changed. This is step 19, in which we repeated the previous steps 2 times, giving us 4 overall inputs, which changed the value of the count to 4. This is step 20, in which we began to build a circuit on the prototyping board using a resistor and an LED light connected in series between the digital output 0 and the ground terminal of the interface board. In step 21, when we ran the program, you can see here that as the logic value becomes 1, the light blinks. As it becomes 0, it doesn't blink. And again, when it becomes 1, it starts to blink again. And when it becomes 0, it doesn't blink. Thus, we were able to verify that the LED light blinked due to our program.